protein journey, from pasture to premium protein. Have you ever wondered about the journey your protein takes before it reaches your shaker? It's a story far more intricate and fascinating than you might imagine, a tale of precision, technology, and an unwavering commitment to quality that begins not in a lab, but under the open sky, on some of the most advanced dairy farms in the world. This isn't just about milk, it's about a liquid gold, transformed.
Look closely.
Before we dive into the modern marvels of protein production, let's take a moment to appreciate the profound connection humanity has with milk. It's a relationship that stretches back thousands of years, long before the advent of robotic milking or molecular filtration. Imagine our ancient ancestors, perhaps around 10,000 years ago, as they began to domesticate animals in the Fertile Crescent. While initially, these animals were primarily for meat, a revolutionary discovery was made: milk. It was a renewable, nutrient-rich food source that didn't require sacrificing the animal. This was a game-changer for early human societies, providing a consistent supply of calories, fats, and proteins, especially crucial for growing populations. However, there was a challenge. Most adult humans in those early days were lactose intolerant, meaning they couldn't properly digest the sugar in milk. But through a remarkable process of natural selection, driven by the immense nutritional benefits of milk, a genetic mutation began to spread. This mutation allowed adults to continue producing lactase, the enzyme needed to digest lactose, into adulthood. This ability, known as lactase persistence, became more common in populations that relied heavily on dairy farming, particularly in parts of Europe, Africa, and the Middle East. It's a fascinating example of how human biology adapted to a new food source, fundamentally shaping our diets and cultures. From simple fermentation into yogurt and cheese, which naturally reduce lactose, to the direct consumption of fresh milk, dairy became a cornerstone of human nutrition, laying the groundwork for the sophisticated industry we see today. This ancient legacy of valuing milk for its life-sustaining properties is the very foundation upon which our modern quest for premium protein is built. Phase 1: Precision Farming, the source of purity. Our story truly begins at dawn, or sometimes, long before it. Picture vast, green pastures stretching across the American heartland, where the air is crisp and the cows, often the iconic Holsteins with their distinctive black and white markings, or the smaller, fawn-colored Jerseys known for their exceptionally rich milk, are the true stars of our show. These aren't just any farms, these are high-tech ecosystems, meticulously managed to ensure every drop of milk is nothing short of perfection. The commitment here isn't just to quantity, but to an unparalleled standard of quality, beginning right at the source. The secret to premium protein starts with what these magnificent animals consume. Their diets are a science in themselves, carefully calibrated by expert nutritionists, often working in tandem with veterinarians and agricultural scientists. It's a precise blend of forages like alfalfa and silage, supplemented with grains, vitamins, and minerals. This isn't guesswork, it's a sophisticated nutritional program designed to ensure the cows are healthy, comfortable, and producing milk that is consistently rich in protein and essential fats. Every ingredient is chosen for its specific contribution to the cow's well-being and the milk's composition. For instance, the protein content in milk can be influenced by the amino acid profile of the feed, directly impacting the quality of the whey protein derived later. It's a symphony of agriculture and animal welfare, where every detail, from the feed composition to the ambient temperature in the barns, is optimized for peak performance and ethical treatment. The health and happiness of the herd are paramount, not just for ethical reasons, but because a healthy cow produces higher quality milk. And then comes the milking, a process that has evolved dramatically over centuries, from rudimentary hand milking to the sophisticated systems of today. Gone are the days of manual labor on many of these cutting-edge farms. Instead, we see the quiet hum of automation. Robotic milking systems, ultra-clean and incredibly efficient, gently attach themselves to the cows. These robots use lasers and sensors to locate the teats, clean them, and then attach the milking cups with precision and care. The cows can often choose when they want to be milked, leading to a more natural and less stressful routine for them. This autonomy contributes to their overall well-being and, consequently, to milk quality. Each cow's milk production is monitored individually, providing valuable data on their health and productivity. It's a marvel of modern engineering, designed to be stress-free for the cows and hyperhygienic for the milk, minimizing human contact and potential contamination. As the milk leaves the cow, it's at a warm 38 degrees Celsius, a perfect temperature for bacteria to thrive and multiply rapidly. But here's where the first critical step in preservation kicks in, a step that is absolutely non-negotiable for quality. Within moments, sometimes even as it flows from the udder through sterile lines, this precious liquid is rapidly cooled to a chilling 4 degrees Celsius. This rapid cooling is achieved using heat exchangers, which quickly draw heat away from the milk. It then flows into gleaming stainless steel tanks, massive, insulated vessels that act as guardians of its freshness. These tanks are not just storage containers, they are precision instruments, constantly monitoring and maintaining the optimal temperature. This immediate cooling is paramount. It dramatically halts bacterial growth, effectively putting any microbial activity into a state of dormancy. This locks in the milk's natural goodness, preserving its delicate protein structures and setting the stage for its incredible transformation into premium protein. This initial phase, this dedication to purity at the source, from the cow's diet to the robotic milking and immediate chilling, is the bedrock upon which all subsequent quality is built. It's a silent promise, made every single day, under the watchful eyes of dedicated farmers and advanced technology, ensuring that only the finest raw material enters the supply chain. Phase 2, the cold chain, a race against time. Once collected and chilled, the raw milk embarks on the next leg of its journey, a high-stakes race against time and temperature. This isn't just transportation, it's a meticulously choreographed logistical operation, a testament to engineering, precision, and an unwavering commitment to maintaining the integrity of the product. Every mile, every minute, is critical. Imagine massive tanker trucks, gleaming chrome behemoths that traverse scenic American highways, often at sunrise, their polished surfaces reflecting the first light of day. These aren't just ordinary trucks, they are, in essence, giant thermos bottles on wheels, purpose-built for dairy transport. Their construction is a marvel of insulation technology. Multiple layers of specialized materials, often including vacuum-sealed panels and high-density foam, create an incredibly efficient thermal barrier. This design is so perfectly engineered that over journeys spanning many hours, sometimes hundreds of miles, the milk inside will typically rise by no more than 1 or 2 degrees Celsius. Think about that for a moment. Maintaining such a precise, near-freezing temperature over long distances, often through varying external conditions, is a monumental feat, absolutely crucial for preserving the milk's delicate protein structures and preventing any bacterial proliferation. The drivers of these tankers are also highly trained, understanding the critical importance of timely delivery and maintaining the cold chain. But the journey isn't just about maintaining cold, it's also about vigilance and an uncompromising commitment to safety and quality. Before these tankers are even allowed to unload their precious cargo at the cheese factory, a rigorous series of admission tests begins. This isn't a formality, it's a non-negotiable checkpoint, a critical barrier against anything that could compromise the final product. Samples are meticulously collected from each tanker, often right at the receiving bay. These samples are then rushed to an on-site laboratory for immediate analysis. They are tested for the presence of antibiotics, which could be harmful to human health and interfere with the cheese-making process. They are also tested for bacterial counts, indicator of freshness and hygiene, and for fat and protein content, which are crucial for the efficiency of the cheese and whey production. These aren't just routine checks, they are absolute requirements, with strict thresholds. If even one parameter is outside the stringent standards, if there's any hint of contamination, an elevated bacterial count, or the presence of antibiotics, the entire load, tens of thousands of liters of milk, is immediately rejected and discarded. There are no second chances, no compromises. This unwavering commitment to quality, enforced at every transfer point, ensures that only the purest, most pristine milk continues on its path to becoming premium protein. It's a silent guardian of your health and the quality of the final product, a testament to the industry's dedication to consumer safety and product excellence. Phase 3, the cheese separation, the birth of liquid gold. Now, the milk arrives at the cheese factory, a place where ancient craft meets modern science, where tradition is enhanced by technological precision. This is where the true magic begins, where milk, through a series of precise biochemical and physical steps, is transformed into cheese, and simultaneously, its often overlooked byproduct is born, liquid whey. This phase is pivotal, as the quality of the whey directly depends on the careful handling of the milk during cheese production. The first crucial step inside the factory is pasteurization. The raw milk, having passed all its rigorous quality checks, is rapidly heated to a specific temperature, typically around 72 degrees Celsius 161 degrees Fahrenheit for 15 seconds in a high-temperature short-time (HTST) pasteurizer, and then quickly cooled. This process is vital. It eliminates any potential pathogens, such as harmful bacteria, viruses, and yeasts, ensuring the milk is safe and sterile for consumption and further processing, all without significantly compromising its nutritional value or flavor profile. It's a quick, efficient cleanse, preparing the milk for its next big change, ensuring a clean slate for the delicate enzymatic reactions to follow. Next comes the coagulation, a fascinating chemical dance that is the heart of cheese making. Specific enzymes, primarily rennet, which can be animal-derived or microbial, along with beneficial lactic cultures, specific strains of bacteria, are carefully added to the pasteurized milk. These ingredients work in harmony. The lactic cultures begin to ferment the lactose in the milk, producing lactic acid, which lowers the pH. This acidification, combined with the action of rennet, causes the milk proteins, particularly casein, to curdle. You can almost see the transformation happening. The milk begins to solidify, forming a gel-like matrix, and then separating into two distinct parts. One is the solid mass, the curds, which are essentially concentrated milk proteins and fats, destined to become cheese. The other is a translucent, yellowish-green liquid. This is the star of our next act, the liquid whey. This separation is a delicate process, requiring precise timing and temperature control. The exact pH, temperature, and duration of coagulation are critical and vary depending on the type of cheese being made, which in turn can subtly influence the composition of the whey. Once the curds and whey have clearly formed and the curds have reached the desired firmness, the liquid whey is carefully drained away from the solid curds. But the process isn't over yet. This raw liquid whey often contains tiny, residual pieces of curd, as well as some fat globules. To ensure purity and prepare it for further processing, it undergoes a final filtration step, typically using screens or centrifuges, removing any remaining solids and excess fat. What's left is a clear, clean, nutrient-rich liquid, a true liquid gold that is packed with high-quality protein, primarily beta-lactoglobulin, alpha-lactalbumin, and immunoglobulins, along with lactose, vitamins, and minerals. It's a testament to the efficiency of nature and the ingenuity of food science, turning what was once considered a waste product into a highly valued nutritional powerhouse, ready for its next transformation. Phase 4, Molecular Filtration, the transformation to premium powder. The journey of our liquid gold isn't over yet. In many cases, the cheese factory that produces the liquid whey isn't the same facility that transforms it into the premium whey protein powder you know and trust. This means our liquid gold must travel again, a critical, time-sensitive voyage, often to specialized whey processing plants designed specifically for this complex task. The liquid whey, which is an astonishing 94% water, is carefully loaded into yet another fleet of specialized tanker trucks. These aren't just any trucks, they are designed to maintain the precise conditions necessary for this highly unstable liquid. Time is of the essence here. Liquid whey is incredibly sensitive to temperature fluctuations. Its high water content and remaining lactose make it an ideal environment for microbial growth if not kept cold. If it warms up too much, even slightly, it can quickly spoil, becoming acidic and unusable, rendering all previous efforts futile. So, the cold chain logistics continue the same rigor as with raw milk, ensuring the whey arrives at the processing plant in perfect condition, ready for its ultimate transformation. Upon arrival at the dedicated whey processing plant, the real magic of transformation begins, a sophisticated, multi-stage process of molecular filtration. This is where cutting-edge membrane technology takes over, meticulously separating the valuable protein from the water, lactose, and fats, refining it to various levels of purity. The first and often primary step involves ultrafiltration, UF. Imagine incredibly fine, semi-permeable membranes, like microscopic sieves, with pores sized to allow smaller molecules like water, lactose, and some minerals to pass through, while retaining the larger protein molecules. The liquid whey is pumped across these membranes under pressure. As the water and smaller solutes are forced through, the protein molecules are concentrated on the other side, making the liquid thicker and richer in protein. This process effectively separates whey protein concentrate, WPC, from the permeate, the liquid that passes through the membrane. For even higher purity, especially to produce whey protein isolate, additional filtration steps are employed. Microfiltration uses membranes with even larger pores than ultrafiltration, primarily to remove fats and bacteria, resulting in an even cleaner protein solution with less fat. Following this, diafiltration might be used. This involves adding purified water to the concentrated protein solution and then filtering it again through ultrafiltration membranes. This washing process effectively flushes away more lactose and minerals, further increasing the percentage of pure protein. This iterative process of concentration and washing is how we get different types of whey protein, like whey protein concentrate, WPC, which typically ranges from 35% to 80% protein, and whey protein isolate, WPI, which is the purest form, often over 90% protein, with minimal lactose and fat. Each filtration step is carefully controlled to preserve delicate structure and biological activity of the whey proteins. Finally, after these intricate filtration steps, we have a highly concentrated liquid protein solution. But it's still liquid. To turn it into the convenient, shelf-stable powder we use, it undergoes a process called spray drying. The concentrated liquid protein is atomized into a fine mist by nozzles and sprayed into a large, heated chamber. As the tiny droplets fall through the stream of hot, dry air, the water rapidly evaporates almost instantaneously, leaving behind a fine, dry powder. This process is designed to be quick and gentle, minimizing heat exposure to prevent denaturation of the proteins. The resulting powder is then carefully collected from the bottom of the drying chamber, often using cyclones, and further cooled. Before packaging, the finished whey protein powder undergoes a final battery of rigorous quality control tests. These include checks for protein content, moisture levels, microbial purity, and absence of contaminants. Only after passing all these stringent tests is the powder deemed ready for packaging. It's then carefully sealed to protect it from moisture and oxygen, ensuring its freshness and potency until it reaches the consumer. From the serene pastures where cows graze, through advanced robotic milking, meticulous cold chain logistics, the precise separation in cheese factories, and finally, the marvel of multi-stage molecular filtration and gentle spray drying, every single step in this journey is a testament to science, technology, and an unwavering dedication to quality. It's a complex, multifaceted process, driven by innovation and a deep understanding of biochemistry and engineering. The next time you mix your protein shake, remember the incredible, unseen journey it took, from a humble farm to a premium powder, ensuring you get the very best fuel for your body. It's a story of transformation, precision, and the relentless pursuit of excellence, rooted in an ancient human connection to milk and perfected by modern ingenuity. Underscore 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 underscore.